Okay, so just a quick reminder, we're going to continue working on solving equations in one variable, but just a couple of reminders. Remember, our goal when solving equations is to isolate the variable. And basically, the way we isolate the variable is we undo what has happened to the variable. So if something has been added to the variable, we subtract it. If something has been subtracted to the variable, we add it. And we have to do this to both sides of the equation. So whatever we add or subtract to the left or from the left, we have to do the same thing to the right. That's how we maintain balance. So an equation comes to us naturally balanced. And as we isolate the variable, what we're doing is we're finding the value for the variable that makes that true, so that keeps it balanced. Okay. But in order to maintain balance, as we move things around, we have to do it to both sides of the equation. Okay. And the first property we talked about was the addition property of equality, which allows us to move terms from one side to the other of the equation by adding or subtracting. So you can add or subtract from the left, but you have to add or subtract from the right. I can't say that enough. You have to maintain balance. So whatever we do to start isolating the variable, we have to do to both sides of the equation. Okay? Now, the goal of this section is to learn the multiplication property of equality. So that is topic 1. Okay, so topic 1, the multiplication property of equality. It is just another property that helps us in our mission to isolate the variable when we're solving a linear equation in one variable. Okay, so it says this property is used when the final variable term has a coefficient other than 1. So when we start getting into more complex equations, this is going to be the very last step. So ultimately, you're going to have a single variable term equal to a single constant term, and that's when you apply the multiplication property of equality. And this property allows us to multiply or divide both sides of the equation by the same number. So if I multiply on the left by something, I have to do the same thing on the right. If I divide on the left by something, I have to do the same thing on the right, okay? Symbolically, what's happening is if we let A, B, and C be real numbers, okay? So they're just some fraction, decimal, integer, whatever. They're real numbers. If A is equal to B, we're already saying, hey, the left equals the right. If we go ahead and divide both sides by the same value C, we're still going to get something that is equal, okay? Dividing the left by C and then dividing the right by C, you're still going to be balanced. Similarly, we could take, again, A equals B, we could multiply the left by something. And as long as we multiply the right by something, we're still equal. Okay, so let's practice this property. Okay, so example 1 says apply the multiplication property of equality to solve each equation. Check the solution. Okay, so for part A, we have -7 times x equals 63. So we have a single variable term equaling a single constant term. You know that's the point where you would apply this property. Single variable term equaling single constant term. And you know this is going to happen when you have a coefficient on the variable other than just 1. Well, we definitely have a coefficient on x here other than 1. In fact, our coefficient is -7. So we have to ask ourselves, what is being done to the variable that we need to undo? Okay, well, x is being multiplied by -7. How would I undo multiplication? Well, remember at one point in a previous video, we talked about inverse operations. Inverse operations are operations, so think addition, subtraction, multiplication, division, and so forth. Inverse operations are operations that undo each other. So addition will undo subtraction, subtraction will undo addition. And then for multiplication, it's division. So division will undo multiplication, multiplication will undo division. Okay, so since we're multiplying x by -7, the way we want to undo that is to divide the left by -7. But if I divide the left in order to maintain balance, I have to also divide the right. Okay, so we're going to divide both sides of the equation by the coefficient of x, which is -7. And let's look at the left-hand side. We have -7 divided by -7. Anytime you take a number and you divide it by itself, you just get +1. So -7 divided by -7 is +1, and 1 times x is just 1x. We don't write the 1, we just leave it as a single positive x. Okay? And then if we scoot over to the right-hand side of the equation, we now have +63 divided by -7. A positive divided by a negative is always going to be negative. And in this case, it's going to be -9. Okay, so let's go ahead and check this. So we want to check x equals -9. I'm going to rewrite the original equation. Anywhere I see an x, I'm going to replace it with a -9. So we have negative 7 times x, which is really negative 9. We want to know, does that equal 63? Well, when we multiply two negatives like what we have on the left, that product is going to be positive. And then 7 times 9 is 63. And we can say 63 really does equal 63. So with confidence, I can say x equals -9. So remember, you'll see a lot of times, you'll see just this notation, the little squiggly brackets or the squiggly braces is what I call them, but they're really called curly braces. When you see these curly braces around a number, we're just saying this is our solution set. So this is quite literally called solution set notation or just set notation. Okay? Let's move on to part B. So part B has a decimal, okay? And remember, during these first couple of sections, I'm reminding you of how to do things by hand. There is a lot of power in just knowing how to do some multiplication, division, addition, and subtraction by hand. Yes, you can use your calculator. No, you will not be penalized if you use your calculator. But there is power in bringing back some of those by hand processes, because every time you stop and remove your eyes from your paper and go over to your calculator, you're losing the rhythm of solving, and sometimes that can throw you off. Okay, so I am for a little bit going to continue to show you how to do stuff by hand while it's still a little bit easier. Get in the practice of practicing some of this, because if you have some stuff up here that you can just bring to the surface, it's going to be helpful. Okay, so let's look at negative 0.4x equals -16. We are at that point where we could apply the multiplication property of equality. We have a single variable term equals a single constant term. I need to undo what has happened to the variable. And in this case, the variable has been multiplied by -0.4. So I need to undo that. The way I undo that is I divide. So remember, we undo multiplication with division. And if I do this on the left, I have to do this on the right to maintain the balance in that equation. Well, looking at the left, -0.4 divided by itself is going to be +1. Remember, anytime you take a number and divide it by exactly itself, it just equals 1. So we get 1 times x. And remember, we don't write the 1 with the x, we just write the x by itself. The 1 is assumed. And now we've got the -16 divided by -0.4. This would be a time that, generally speaking, we would all use our calculator. But I do want to remind you how to do some quick division with decimals. So what's happening here is we have -16 divided by -0.4. Okay, 16 is called the dividend. That's what's being divided. -0.4 is called the divisor. It's what's doing the dividing. And when we go to divide decimals by hand, the issue is we don't know how to divide when the divisor is a decimal. So what I would have to do is multiply my 0.4 by 10. When I multiply the 0.4 by 10, that just gives me -4. Okay, I need the divisor to be a whole number or an integer. Okay, but if I multiply the denominator by 10, I have to multiply the numerator by 10 as well. Otherwise, it's no longer the same. They're no longer equal, right? So I'm going to multiply the top by 10 as well, which makes that -160. Well, this is going to be a lot easier to divide. Again, we don't know technically how to divide when a divisor is a decimal. So once we make the divisor a whole number or an integer, we can just go ahead and set up for long division. So I want to take my 160 and divide it by 4. We'll deal with the signs in just a second. So 4 will not go into 1, but 4 will go into 16. It'll go in 4 times. 4 times 4 is 16. I subtract, I get a 0. Now, ordinarily, when we get a 0 remainder, we're done. However, we still have a number from the dividend that we need to drop down. And as long as you have numbers in the dividend that have to be dropped down, you have to continue dividing. So I want to drop down this 0. And once I drop something down, I have to put something in my quotient. So 4 goes into 0 times. So we put a 0 up here. 0 times 4 is 0. And now we truly have a 0 remainder. There's nothing left in the dividend to drop down, so we are done with this process. So we can now say that 16 divided by 0.4, or 160 divided by 4, is 40, and we just want to double check our signs. When you take a negative and divide it by a negative, you get a positive. So this really is going to be +40, okay? And if you want to check it, you can. The directions do say to check it. There's going to come a point where we won't check as often just because of the time, honestly. But know how to practice checking so that if you ever get in a position where you're like, I don't know how this looks, you can always check your answer to see if you're right or not. So what we want to do is take -0.4, multiply it by 40. We want to know, does that equal -16? Well, I'm going to take my 40. I'm going to multiply it by 0.4. We'll worry about the signs in a minute. 4 times 0 is 0. 4 times 4 is 16. And the trick when you're multiplying decimals is you right-hand align them. You don't worry about lining up decimals or anything. And then you add the number of decimal places you have in your factors. Well, there are 0 decimal places in this factor. There's 1 decimal place in the second factor. That means the sum of those two is how many decimal places I need in my answer. So I have 1, 0 plus 1 is just 1. So I need 1 decimal in my answer, which makes that 16. But we had a negative times a positive, so that's really going to be negative 16. Does negative 16 equal negative 16? Yes. So we verified that 40 really is our solution. So we could say x equals 40. Okay? So let's go ahead and look at the next two, and then that'll be the end of this video. All right, so C is a little bit tricky. Some of us get it right off the bat. Others, it takes a little bit of work. So we have negative x equals 5. On the surface, it looks like we're done. We've got x, a single x, and we've got it equal to a constant. The issue is the negative. So one thing I need to remind you all is that we don't put the ones with our variables. They're assumed. But in a situation like this, when your variable is negative, we do have to do some work because you're not fully solved until you get a single positive variable equaling a constant. So the issue is this negative right here. So this is really the same as negative 1 times x equals 5. So now you can see that x really does have a coefficient. X is being multiplied by negative 1. So the way we would undo multiplication by negative 1 is we would divide both sides by negative 1. Well, negative 1 times negative 1 is just 1. So 1 times x, we just get our single positive x. But now 5 divided by negative 5, or excuse me, 5 divided by negative 1 is negative 5. So now we can say we're truly solved. We have a single positive x equaling some constant value. So let's check. So we're going to check x equals negative 5. So I'm going to go back to my original equation. Remember, negative x is the same as negative 1 times x, and x is negative 5. Now we need to know, is negative 1 times negative 5 equal to 5? Well, yeah, if you multiply two negatives, it becomes positive. So 5 really does equal 5. We're good. And we can say the solution here is negative 5. Okay? Last up for this video, we have part D. We have 3 times y equals negative 4/9. Now, math students worldwide, anytime they see fractions, they're kind of like, oh, fractions are not necessarily difficult. It's just extra steps, okay? So don't get too bent out of shape anytime you see a fraction. Just take it nice and slow. Know how to work with fractions. Remind yourself how to add, subtract, multiply, and divide, okay? Now, in this case, we want to isolate the y. Y is being multiplied by 3. So because I have that single variable term including that single constant term, I'm ready to apply the multiplication property of equality. I need to undo the multiplication of 3 and y. So I divide both sides by 3. And over here on the right, I'm going to write it more like traditional division, okay? So looking at the left again, 3 divided by 3 is just 1. 1 times y is just y. Now, for the right, I'm going to do a little work with my fractions. I have negative 4/9 divided by 3, but I'm going to write it in fraction form. So I'm going to write it as 3/1, okay? Now, hopefully you remember there's a trick to division. We technically don't know how to divide fractions, but we do know how to multiply. So if we can find a way to convert division into multiplication, we're good. And we can. The way we do that is we multiply the first fraction by the reciprocal of the second fraction. So when you have a fraction, to find its reciprocal, you just flip the fraction upside down. So instead of dividing by 3/1, I want to multiply by 1/3. And so after doing a little bit of work, I can see that the numerator here is just negative 4, so that's got factors of 2. The denominators are 3 and 9. 9 has factors of 3. Nothing's going to cancel here, so I would say my final answer is negative 4/27. Now we can check that, okay? So when I check this, I get 3 times negative 4/27, hopefully equals negative 4/9. I'm going to go ahead and write this 3 as 3/1 times negative 4/27. Now, in previous videos where I talked about multiplying and dividing fractions, we like broke down the factors. We broke down the numbers, the numerators and denominators as factors. Here, I want you to really get to the point where you can sort of do some of this in your head. 3 and 27 are both divisible by 3. So what we're going to do is we're going to say, okay, 3 is divisible by 3, so 3 divided by 3 is 1. 27 is divisible by 3. 27 divided by 3 is 9. So now let's clean up the left-hand side. I have 1 times -4. My denominator is 1 times 9, and that just so happens to equal exactly -4/9. So we were able to check it. Our solution of -4/27 is good, so we're going to write it in set notation. And that's it. So that is how you apply the multiplication property of equality. At some point, we'll eventually get to more complicated equations where we have both properties together, or we have to do a lot of simplifying before we can get to the point where we apply both of these properties, but make sure you practice them individually on their own.